friends, in this session we are going to consider multiple choice questions on topic partial differentiation. This is a very important topic. Topic name it is partial differentiation. Now when we come across a function where there are more than one independent variable, so if we have function with more than one independent variable, then we consider partial differentiation, partial derivative. And the notation for this, we'll use gamma. It is also called as a delta. Okay. For example, suppose we have z is equal to x square plus y square. So you can see that x and y are independent variables. Now, how many variables are these? There are two variables, and we can take derivative of z, which is dependent variable, with respect to independent variable x. The notation we are using is dabba z by dabba x, not dz by dx. While taking derivative with respect to x, treat another independent variable y as a constant. So it is 2x and derivative of y square will be 0. So it is finally 2x only. Similarly, we may have the derivative of z with respect to y, that is dabba z by dabba y. Now, but with respect to y, we will treat x as a constant. So derivative of x square will be 0 and derivative of y square is a 2y. So it is equal to 2y. Let's consider one more example. Suppose we have u is equal to x cube plus e raised to x y z plus y square z. And here we have x, y and z as independent variables and u is dependent variable. So derivative of u with respect to x, that is dabba u by dabba x, but by treating y and z constant, so it will be 3x square plus e raised to x y z into yz plus derivative of y square will be 0. So that is 3x square plus e raised to x y z. This is dabba u by dabba x. Similarly, we can have the dabba u by dabba y and dabba u by dabba z. While taking derivative with respect to y, treat x and z constant. While taking derivative with respect to z, treat x and y constant. This is how we apply the partial differentiation. Now in this topic, for multiple choice questions particularly, we will have the examples on direct differentiation, direct derivative, where we have the more than one independent variable. Second, we may have some of the examples where variable to be treated as constant, variable to be treated as constant. So that I will explain in the example itself. Third, we will have the examples on homogeneous function, of 2 and 3 variables, homogeneous function of 2 and 3 variables, particularly for finding the degree. Then we may have the examples on Euler's theorem, which is basically for the homogeneous function. Then we will have the examples on reduction of Euler's theorem, is also called as Euler's second theorem. Then we may have some of the examples on change of independent variables, or we may simply call it as a chain rule related to the functions of variables or functions containing more than one independent variable. And some examples we may have on the total derivative concept. Total derivative. These are the points where the questions may be asked for multiple choice questions, right? Let us go for the first example. Here u is equal to tan inverse of y by x. So you can see that x and y are two independent variables. So while finding dabba u by dabba x, we will treat y as a constant. And what is u? U is a tan inverse of y by x. So we know that derivative, basic formula derivative of tan inverse of x is 1 upon 1 plus x square. So by using that, derivative of tan inverse of y by x will be 1 upon 1 plus y by x bracket square. But into we have to apply the derivative of y by x with respect to x, treating y constant. So that will be minus y upon x square, because y is a constant and derivative of 1 upon x is minus 1 upon x square. Just simplify this. It is 1 divided by x square plus y square upon x square into minus y upon x square. Further, this will get inverted and x square will cancel with this x square. So finally we will have minus y upon x square plus y square. So the correct answer for this is option C. This is an example on direct derivative. We have to take the derivative directly by treating proper variable as a constant. Now next we have, if u is equal to log of under root x square plus y square. So u is log of under root x square plus y square. Now again you can see that x and y are two independent variables. And question is about u suffix x, and that u suffix x means what? Dabba u by dabba x. So taking derivative with respect to x, treating y constant. So initially basic formula of log, its derivative is 1 upon under root x square plus y square. Now we have to apply the chain rule. Into derivative of root x square plus y square is 1 upon 2 root x square plus y square. Into again derivative of x square plus y square with respect to x, and y constant is 2x. So it is finally that 2 will cancel. It is finally what? X upon x square plus y square. So option A is the correct answer for this. Now simple examples. Now this is u is equal to sin inverse of xy. Now we must know the formula for derivative of sin inverse of x. So here u is equal to sin inverse of xy. So dabba u by dabba x, that is u suffix x, is first formula for derivative of sin inverse, that is 1 upon under root 1 minus x square y square, you will say xy bracket square, that is x square y square, into derivative of xy with respect to x, y constant is y. it is finally y divided by under root 1 minus x square y square. So answer is option D. In this example, this is the concept of the variable to be treated as constant. Now here, when you come across suffix outside the bracket, so that means what? That variable you have to treat as a constant. Means the meaning of this dabba r by dabba x, outside there is a y. It means what? Partial derivative of r with respect to x, treating y constant. Means in this example they have mentioned which variable you have to treat as a constant. And the basic requirement for this is what? We must have this upper variable in terms of this denominator variable x and outside variable y. Means we must have r in terms of x and y. We must have r in terms of x and y. If you see the given equations, x is in terms of r theta, y is in terms of r theta. But we need what? R in terms of xy. So we'll find out that r in terms of xy, and obviously not containing theta. It means we have to eliminate theta from this given two equations. So it is simple, the relation between Cartesian and polar. So if we do the square and add, means x is equal to r cos theta, y is equal to r sin theta. Simply square and add these two equations. So we'll have that x square plus y square is equal to r square into cos square theta plus sin square theta. So this will give you r square is equal to x square plus y square, because what basic trigonometric identity cos square plus sin square is 1. So now we have that r square is equal to x square plus y square. So we have that r in terms of x and y, or r term in terms of x and y. Now differentiate this partially with respect to what is required, with respect to x, and treating, obviously as per the requirement, treating y constant. So it is the root of r square, it is a 2r into dabba r by dabba x, treating y constant is equal to the root of x square plus y square will be 2x plus 0. So we have it is dabba r by dabba x, treating y constant is equal to 2x upon 2r, that is x upon r. So what is the answer for this question? It is option A, x upon r. Next we have similar, x is equal to e raised to u cos v and y is equal to e raised to u sin v. And the question is to find dabba u by dabba x, obviously by treating y constant. So dabba u by dabba x, we must have u in terms of x and y, u in terms of xy, and obviously not containing which variable? V. Means we have to eliminate v from given equations. So you can see that here it is e raised to u cos v, and it is e raised to u sin v. So again similarly you can do the square and add. So squaring and adding given equations, we will have that x square plus y square is equal to e raised to u. x square plus y square is equal to e raised to u. Now differentiate this. We have that u term. It is not exactly u, but it is a u term in terms of x and y. You can take derivative of this, differentiate with respect to x and treat y constant. So what we will have? Derivative of e raised to u will be e raised to u into dabba u by dabba x, treating y constant, is equal to derivative of x square plus y square will be 2x. So that is dabba u by dabba x treating y constant will be equal to 2x upon e raised to u. But what is e raised to u? That e raised to u is x square plus y square. You can put that 2x upon this e raised to u is x square plus y square. So we have the answer, dabba u by dabba x treating y constant is equal to 2x upon x square plus y square. Now if you see the options, you have to do some changes in the option. Let us consider this as a 2x upon x square plus y square. So with this change, the option A is correct answer. Similarly, you can solve this example. Here, directly you have to take derivative. There is no question of expressing or elimination. Directly we have dabba u by dabba y. So put x as a constant. So it is basic formula of log, it is 1 upon 2x plus y. And the derivative of 2x plus y is 1. Answer will be 1 upon 2x plus y. So dabba u by dabba y is equal to 1 upon 2x plus y. And again you have to make certain changes according to the question here. Actually here if we take 3y, then we may have the option. So if we take 3y, it will be changed as a 3. The root of 3y will be 3. So the answer will be 3 upon 2x plus 3y. It is option B. So with this correction, the answer will be this. In exam, you have the question where there will be no errors or mistakes. Now here, u is equal to x raised to y plus y raised to x and dabba u by dabba x. So what is u here? X raised to y plus y raised to x. Then dabba u by dabba x will be equal to, with respect to x, we will treat y as a constant. So this y is a constant. Derivative of x raised to y will be y into x raised to y minus 1. Plus derivative of y raised to x will be y raised to x into log of y. Using the basic formula that d by dx of x raised to n is equal to n x raised to n minus 1, and d by dx of a raised to x is equal to a raised to x log a. Okay, so with this we have this. The answer will be y into x raised to y minus 1, y raised to x log 1 is option A is the correct answer. Now this is on the implicit function. Implicit means what? When you are not having that y in terms of x or x in terms of y, but the equation is containing the mixture of x and y. In that case, you have to simply write down that equation into equal to 0 form, call that as a f of xy, and then dy by dx is given by minus dabba f by dabba x upon dabba f by dabba y. This dabba f by dabba x we also denote by p, and this dabba f by dabba y we also denote by q. So that dy by dx is equal to minus p upon q. And you note that here we are not having the notation dabba to the dy by dx. The reason is what? There are not more than one independent variable. The equation is containing two variables x and y. So out of the two variables, one is dependent and one is independent. So the derivative will be ordinary, not partial, dy by dx. So answer for this is this dabba by dabba x means fx and dabba by dabba y means fy. So the option A is the answer. Let us move further. Here the question is about the second order derivative. Here we have x u is equal to u is equal to x raised to y. So if we differentiate it with respect to y, so now with respect to y, obviously we treat x as a constant. So x is constant. So what is the derivative? X raised to y will be x raised to y into log x. Again one more derivative, second order derivative it is. So again differentiating, we will have dabba square u by dabba y square is equal to, now is x raised to y and log x. So log x is constant with respect to y, and derivative of x raised to y will be x raised to y into log of x. It is finally what? Log of x bracket square into x raised to y. So what is the answer? Log x bracket square into x raised to y. Option B is the correct answer for that. In this, we have that u in terms of xy and xy in terms of t. So simply we can say it is a chain rule for example. Now u is in terms of xy and xy in terms of t. That means u is composite function of t. So when you want derivative of u with respect to t, you have to go through x and y. So that dabba u by dabba t is equal to dabba u by dabba x into dabba x by dabba t plus dabba u by dabba y into dabba y by dabba t. And this we may also consider as a du by dt, because that u is a function of single variable t. So with this we will have that dabba u by dabba x required into dabba x by dabba t plus dabba u by dabba y into dabba y by dabba t. So answer is option A, dabba u by dabba x into dabba x by dabba t plus dabba u by dabba y into dabba y by dabba t. So more correctly, if we consider x as a function of t, single variable, so that change will be dabba u by dabba x into dx by dt, and similarly for y with respect to t, that is dabba u by dabba y into dy by dt. So if we consider that x and y as a function of single variable, instead of dabba we have to consider d, so that okay, so in option C we have that notation. So the most correct answer is this option C, but this you have to consider as a du by dt. This is simple chain rule. You look in diagrammatic form also, u in terms of x and y and xy in terms of t. You have to go to t, but through x and y, u with respect to x, with respect to t plus u with respect to y, y with respect to t. There are some examples on this concept also, we will see that later. Now most important thing, that is homogeneous function of two variables particularly. If we have suppose u equal to f of xy, u is in terms of two variables x and y, then u is said to be homogeneous function of two variables x and y of degree n if you can simplify that u as x raised to n into f of y by x, or you can simplify that u as y raised to n into f of x by y, or third, which is very simple, that f of tx ty simplifies to t raised to n into f of xy, any one of this, then that u will be called as a homogeneous with degree n. For example, suppose you have u is equal to x square plus y square. Now this we can simplify as x square into 1 plus y by x bracket square. So it is in the form of x square f of y by x. So it is in this format, x raised to n f of y by x. So it is a homogeneous with degree n is 2 here, so degree 2. Or you may write this as, taking y square common, it will be x square or x upon y bracket square plus 1. Because in this form y raised to n f of x by y, second form, same example. So it is homogeneous with degree, homogeneous with degree 2. Or you may consider third criteria, that f of tx ty. Just replace x by tx and y by ty. So it is a t square x square plus t square y square. Take that t square common, so into bracket what remains, x square plus y square. So t square into this x square plus y square is f of xy. So it is in this third form, t raised to n f of xy. So it is again by third criteria also it is homogeneous with degree 2. You may apply any criteria, you will get the same result. It will not happen that by first criteria you are getting degree 2, by another criteria you are getting degree 3. If it is homogeneous, it will be homogeneous with same degree by any criteria. Now in this example, it is a pure theoretical example. As we have written here, this is u is homogeneous function if x raised to u is x raised to n into f of y by x, means this is the correct option. Here it is f of x by y, so it is wrong. Y raised to n, but here it is a y by x, it is also wrong. Y raised to n, it is also correct. So there are two correct options, option A and option D. Okay. Now we have the example depending on that homogeneous concept. So what is, we have u equal to f of xy format. So what is f of xy? We have f of xy is a sine of x square plus y square upon xy. And to check whether it is a homogeneous or not homogeneous, we simplify the f of tx ty. Replace x by tx and y by ty. So it is sine of t square x square plus t square y square upon tx ty. So let us simplify it. It is equal to sine of, from numerator we will have t square common, denominator also t square, that cancels. So what remains? Only sine of x square plus y square upon xy. Now it is the f of xy itself. So we got that f of tx ty is equal to f of xy. So we can write it as a t raised to 0. So we have that f of tx ty in the form of t raised to n f of xy. So by the criteria of homogeneous, the given thing or given function is homogeneous with degree 0. So here the answer is option C. Similar, now this is very simple, that u is equal to 1 upon x raised to p, we can have x raised to minus p, f of y by x. So by the first criteria, this is x raised to n, f of y by x form. N is a minus p, so it is a homogeneous with degree minus p. So option B is the correct answer. Now the degree of this homogeneous function. So what is f of xy here? F of xy is x raised to 6, y raised to 6 upon x raised to 6 plus y raised to 6. Let us simplify f of tx ty. That is a t raised to 6, x raised to 6, t raised to 6, y raised to 6 divided by t raised to 6, x raised to 6 plus t raised to 6, y raised to 6. So it is t raised to 12 into x raised to 6, y raised to 6 divided by t raised to 6 into x raised to 6 plus y raised to 6. So by law of indices, it is a t raised to 6 into x raised to 6 plus y raised to 6 upon x raised to 6 plus y raised to 6. So it is a t raised to 6 into, now this is f of xy. So we have that f of tx ty in the form of a t raised to n f of xy with n as a 6, so that it is homogeneous with degree 6. Option A is the answer. Now this is on the Euler's theorem. Now what is Euler's theorem? For function of two variables, homogeneous function of two variables. If u equal to f of xy is homogeneous with degree n. Then we have two results in Euler's theorem. First one is x dou by u by dou by x plus y dou by u by dou by y is equal to n into u. And second result we have x square dou by square u by dou by x square plus 2xy dou by square u by dou by x dou by y plus y square dou by square u by dou by y square. This is equal to n into n minus 1 into u. It is u. Okay. Now in this example you can see that u is given as a sine inverse of x minus y upon x plus y, and it is homogeneous, because if you simplify that f of tx ty, it will be f of tx ty will be equal to t raised to 0 f of xy. So it is homogeneous. It is homogeneous with degree n equal to 0. And the question is about this x dou by u by dou by x plus y dou by u by dou by y. So by Euler's theorem it is n into u. That required x dou by u by dou by x plus y dou by u by dou by y is equal to n into u. N is 0, so 0 into u, that is 0. So answer is option B. This is the example on Euler's theorem. We have more example on Euler's theorem. Now this given u is x cube plus y cube upon x cube plus y cube. So that f of xy is this thing. This is f of xy. It will be t raised to 6 x cube y cube upon x cube plus y cube. This will be your f of tx ty after replacing x by tx and y by ty. So it is a t raised to 6 and f of xy again. So the given function u is homogeneous with degree n equal to okay, we have done here one error, that t raised to 6, and in denominator we have t cube. So it will be not t raised to 6, it is t raised to 3 into f of xy. So n degree is 3, and by Euler's theorem that x dou by u by dou by x plus y dou by u by dou by y will be equal to n into u, that is 3 into u. So the answer is option A. Now you can see that there is a 6u is also option. If your degree is 6, if you have not corrected this, your answer will be 6, so that which is wrong. Okay, so to take care of that degree, your degree must be correct. Here is a pure theory example. U is homogeneous in x and y with degree n. So it is n u directly. How is this? U is equal to cosec inverse of x raised to under root x raised to 1 by 2 plus y raised to 1 by 2, then degree of u. Actually it must be not degree of u, it must be degree of cosec u, because as it is, if you consider u, it is not homogeneous, because if you replace that x by tx and y by ty, that t will remain inside and that t we cannot take outside because of that cosec inverse. So in this type of thing, if that function you want to be homogeneous, then that t must cancel inside that. If that t is not cancelling, that cannot be homogeneous. So it is a cosec inverse u is equal to cosec inverse of under root x raised to 1 by 2 plus y raised to 1 by 2 upon x raised to 1 by 3 plus y raised to 1 by 3. So this thing we call as a by shifting cosec. So it is a cosec u is equal to under root x raised to 1 by 2 plus y raised to 1 by 2 upon x raised to 1 by 3 plus y raised to 1 by 3. Now if we call this as a z, Now this Z can be homogeneous or cosecant can be homogeneous provided it must be in the form of t raised to n f of xy. This is f of xy. This thing is f of xy. So that f of tx ty will be equal to under root t raised to 1 by 2 into bracket x raised to 1 by 2 plus y raised to 1 by 2. Replacing x by tx, y by ty and taking common, divided by t raised to 1 by 3 into x raised to 1 by 3 plus y raised to 1 by 3. So that will be t raised to 1 by 2 raised to 1 by 2 because of that root, divided by t raised to 1 by 3 raised to 1 by 2, and the remaining that x raised to 1 by 2 plus y raised to 1 by 2 divided by x raised to 1 by 3 plus y raised to 1 by 3 will be as it is. So you can see that this is t raised to 1 by 4 upon t raised to 1 by 6, and this is f of xy again. So it is t raised to 1 by 4 minus 1 by 6 into f of xy. You just have to simplify this. So it is a t raised to 6 means 2 by 24 into f of xy. This is our f of tx ty. And further simplification is t raised to 1 upon 12 f of xy. So it is in the form of that t raised to n f of xy. N is 1 upon 12. So it is homogeneous with degree 1 by 12. So with the correction that degree of u is not, it is degree of cosec u, or you may call that as cosec u as a z. Next, u is a homogeneous function of degree n in x and y, then by Euler's theorem. So as we have written this in the previous slide, it is n into n minus 1 into the second derivative of Euler's theorem. Now take the example on that second result. U is equal to log of x cube plus y cube, then the value of x square dabba square u by dabba x square plus 2xy dabba square u by dabba x dabba y plus y square dabba square u by dabba y square. It is basically on the second theorem, reduction of Euler's theorem. Now what it states, statement if Z is homogeneous function of xy with degree n, and Z is also equal to f of u. In Z we have in two forms. First, that Z is in terms of x and y, and the second, that Z is also in terms of u. Then we have first result, x dabba u by dabba x plus y dabba u by dabba y is equal to n into f of u upon f dash of u, and this will call as a g of u. And the second result we have x square dabba square u by dabba x square plus 2xy dabba square u by dabba x dabba y plus y square dabba square u by dabba y square is equal to g of u into bracket b dash of u minus 1. So here in this example, that u is given as log of x cube plus y cube. This is not homogeneous, because if you consider this as a f of xy, and if you simplify that f of tx ty, that f of tx ty will not be equal to t raised to n f of xy. This u as it is not as a homogeneous, but if you take antilog on both sides, we will have that e raised to u is equal to x cube plus y cube. We call this as a z. So z we have in terms of xy as x cube plus y cube. It is homogeneous. It is homogeneous with degree n equal to 3. and also that z is in terms of u. So it comes in the format of this reduction of Euler's theorem, or you may say second Euler's theorem. So by that, x square dabba square u by dabba x square plus 2xy dabba square u by dabba x dabba y plus y square dabba square u by dabba y square will be equal to this. But for that, we have to first of all find out g of u. Now what is that g of u? G of u is n into f of u upon f dash of u. n is 3, f of u is e raised to u, and f dash of u is, the derivative of e raised to u is e raised to u, so it is a 3. So we got that g of u as a 3, and by this result, means if you put that g of u here, you get the required, we will have that 3 into derivative of 3, that is 0 minus 1, means it is finally minus 3. So correct answer for this is option B. This is not Euler's theorem, this is on the second Euler's theorem, reduction of Euler's theorem. Next, z is homogeneous. So this statement already we have discussed here. This is z is in terms of x and y with degree n, and z is also in terms of u, then that s dabba u by dabba x plus y dabba u by dabba y will be equal to n f of u upon f dash of u, option C. Your theoretical question. Now this is f is equal to x into f of y by x. Now you can see that this is already in the standard homogeneous format. So which format is x raised to n f of y by x, means it is for the homogeneous function. So by Euler's theorem, this will be equal to x instead of f, you must have there u. So that x dabba u by dabba x plus y dabba u by dabba y will be equal to n into, this will be equal to n into u. So what is n? N is 1 here, x raised to n, x raised to 1, so 1 into u. So 1 into u, that is f. So in option also we have to change that as 2u minus 2u, u and minus u. So the correct answer will be this option C. Next, u is equal to f of r, and x is equal to r cos theta, y is equal to r sin theta, and question is to find dabba u by dabba x. So first of all, you have to write down that r in terms of x and y. So we have that r is equal to r, x is equal to r cos theta, and y is equal to r sin theta. So by squaring and adding, it is x square plus y square is equal to r square, or r is equal to under root x square plus y square. So we have that u is equal to f of under root x square plus y square. So that dabba u by dabba x will be equal to f dash, derivative of this f dash, change rule, f dash of under root x square plus y square into derivative of under root x square plus y square, that is 1 upon 2 root x square plus y square into 2x. So that 2 will cancel. It is f dash of under root x square plus y square into this x upon under root x square plus y square. Now let us put that again in the previous notation. This root x square plus y square is r, and x is equal to r cos theta. So using that, it is f dash of r into r cos theta divided by this r. So this will cancel. So answer is f dash of r into cos theta. Or as per the options, if you put this thing as it is, means this x, if we remain as it is f dash of r into x upon r. Now it tallies with the option B, x f dash of r upon r. So option B is the correct answer. This is our total derivative, simple. That phi is given as x square plus xy plus y square minus z square. So instead of d phi by dx or d phi by dxy, notation is d phi only. That d phi indicates the derivative. So if you differentiate this, but we are not mentioning with respect to x with respect to y, it is the total derivative. So differentiating this, derivative of phi will be d phi, derivative of x square will be 2x, attach dx, For derivative of x into y, you have to apply the product rule. X into derivative of y dy plus y derivative of x dx. This is the product rule. The derivative of y square is 2y dy and derivative of z square is 2z dz. You just collect the px terms and dy terms together. So it is 2x plus y dx, 2x plus y dx plus dy terms x plus 2y, that is x plus 2y dy minus 2z dz. So answer it is option A, 2x plus y dx plus x plus 2y dy minus 2z dz. Next, z is equal to f of uv. U and v are given and a question is about x. Okay, so here u is given as in terms of u, sorry, z is given as in terms of u and v, and u, v are given in terms of x and y. So that z is composite function of x and y. Diagrammatically you can have in this way, z in terms of u and u and v are in terms of x, y. So to obtain the derivative of z with respect to x or with respect to y, you have to go through u and v. So that required dabba z by dabba x will be equal to dabba z by dabba u into dabba u by dabba x plus dabba z by dabba v into dabba v by dabba x. Just simplify it. Dabba z by dabba x will be equal to dabba z by dabba u. It is as it is because we don't know what exactly that z is in terms of u and v. And dabba u by dabba x is 2x minus 2y plus dabba z by dabba v will be as it is, and dabba v by dabba x will be 0. So it is 2 into x minus 1 dabba z by dabba u. The required dabba z by dabba x is equal to this 2x minus y dabba z by dabba u. So option A is the correct answer. Simply we are using this derivative of a composite function. Same question we have. Now the changes with v and u. Z is in terms of uv and u and v are in terms of xy. So to obtain the derivative of z with respect to x or with respect to y, you have to go through u and v. So here z with respect to u and u with respect to y. Z with respect to v and v with respect to y. Addition of these two means dabba z by dabba y will be equal to dabba z by dabba u into dabba u by dabba y plus dabba z by dabba v into dabba v by dabba y. That is, dabba z by dabba u will keep as it is because we don't have that z exactly in terms of u and v. Dabba u by dabba y will be minus 2y. Dabba z by dabba v as it is, and dabba v by dabba y is 2x. So it is simply minus 2y dabba z by dabba u plus 2x dabba z by dabba v. So option B is the answer. Next, it is a z cube minus xz minus y equal to 1. Now it is a particularly implicit type, but we will not apply the concept of infinite function. Whatever the derivative we want, dabba z by dabba y, so we will treat x as a constant because z is upper variable, means z is a dependent. There are two independent variables x and y. So with respect to y, treat x as a constant. That is taking derivative with respect to y, treating x constant. So it is 3z square derivative of z cube attach dabba z by dabba y minus x constant derivative of z is dabba z by dabba y and derivative of y is 1 equal to 1. Just simplify it. Dabba z by dabba y into bracket 3z square minus x minus this 1 is equal to, okay, so it is dabba z by dabba y is equal to, this will be minus 1, it will go to the right hand side, so it will become 1 plus 1, that is 2 upon this 3z square minus x, 2 upon 3z square minus x. The answer for this will be, okay, we have to make it changes here, must be 2 upon, not 0, 2 upon 3z square minus x, so with that option A will be correct.